Okay, so last week we were looking at different types of forces and we were looking at normal and all kinds of things. Now, as I'm sure you can understand, it's really important when we talk about forces to kind of show which direction they're going in, right? Because if I need equal and opposite force to stop something, or to make something happen, I would need to understand what that initial force is. And so that's why when we talk about forces, we always talk in terms of vectors. Now, things can have two different types of measurement. You can have scalars and vectors. Okay. Now, a scalar is like, let's think about jumping on a scale. When we jump on a scale, it gives us our mass. Okay. So let's say your mass is 22 kilograms and you are actually just a potato chip. Um, Imagine a potato chip that's 22 kilograms. Anyway, so that would be a scalar. But now a vector would be your weight. Okay. And the reason your weight is a vector is because we're looking at mass times gravitational acceleration. Okay. Now, gravitational acceleration is acceleration, and acceleration is always in a specific direction, while mass doesn't have a direction. Acceleration does. Okay, so we've got speed. Is speed a scalar or a vector? Does speed have a direction? Really? So if I reverse my car, does it tell me that I'm going negative 20 kilometers an hour?
No.
Okay, so that's your speed. Speed is a scalar. However, if I talk about velocity, that is going to be a vector. Okay? But what that means is if I have a windy road and I'm traveling at 100 kilometers an hour, I'm going to travel along that windy road, and it is going to measure the path my tires took. However, if I were to measure the velocity of that car, I'm not measuring as the tires move, I'm measuring the distance, the time it takes. So distance over time, well, it's going to be displacement over time. The displacement of that car from point A to point B. So let's pretend there's a windy road. My velocity is going to be much less than my speed because it took me very long to get a short distance, really, because my displacement was shorter than my actual distance traveled. Okay? So that's where we've got distance and displacement. Now, things that are scalars in life. We've got distance. Distance is your scalar. Displacement would be your vector. Speed would be your scalar. Velocity would be your vector. Mass would be your scalar. Weight would be your vector. Then force, acceleration, and momentum are all vectors. But then we've got a bunch of scalars as well. We've got energy. Energy doesn't have a direction. So it is a scalar. Volume, no direction, so it's a scalar. Density, no direction, so it's a scalar. Temperature, scalar, and power, all scalar. Okay? So the reason a force is a vector is because a force has to be in a specific direction. Okay? So if I push to my right and I'm pushing at 5 newtons, but there's also a downward force of 2 newtons. Okay? My force needs to be in a specific direction. So if there's a force going down and there's a force going to the right, to counteract that downforce, I'm going to have to push like that, right? So if I draw a little triangle, and let's say I've got 2 here and 5 here, I can work out using Pythagoras, this horizontal line is 5 and the vertical line is 2, then I can use Pythagoras to find this hypotenuse. Does that make sense? So I would say 2 squared, so 4 plus 25 is 29. I'm going to square root that. That gives me 5.38 newtons. So that's the actual applied force. Does that make sense? Yeah. And so I'm actually going to do that at an angle. So I'm going to